Good afternoon, everyone. Today we're going to continue our discussion on machine learning. So the packages that we're using, quant mode, TTR, tidyverse, lubridate, etc. We started discussing this the past two sessions, and let's have a quick review. We are downloading some prices from assets from Yahoo Finance, and the start date is 2015-01-01. The end date is 24/12/31. So let's have a quick review here. I'm loading this. And the difference between what we discussed before and now is that I'm creating, before it was only USD PHP. Now I'm renaming it and making it full, okay, so that we preserve the original data, which contains the open, high, low, close, the volume, and then the adjusted prices, and then just create another data for the closing price. Okay, so if you run this, and then we get how many missing values are in USD PHP closing, we get from the previous one, we had three, right? Three missing values. Okay, here three. And we still have this object USD PHP full. Let me just USD PHP full, this one, which contains the original exchange rate downloaded from Yahoo Finance. It contains the opening, the high, low, close, the volume, and then the adjusted. Okay. What is this for? We will be needing the high, low, okay, because we have the closing here. We'll be needing the high and low later on when we go to the Active Directory index. So that's why we're preserving it. Okay, so nothing changed with respect to VIX. Still the same. Okay, no change here. And then we also checked how many missing values there are in VIX. We learned that there are 92. Okay, and we have dealt with this before. Also for Brent, there are two missing values. Okay, in case you find it quite too fast and you would want me to repeat a particular portion, please do not be ashamed to raise your hand. I'm very much willing to do that. I again apologize for the speed in the discussion because, as I said, as you know, this is just a review of what we have discussed. Okay, and we know that we have to deal with the missing values for our objects. The closing price of the exchange rate of dollar and peso has three missing values. The volatility index is 92 and the Brent oil price is 2. Okay, so we said last time, again by way of review, that if we were only analyzing VIX, the volatility index, it does make sense to perform the last observation carried forward, because logically what it does is it will forward fill, okay, the missing data. Okay, so and it's logical, since if you have, let's let's view this class. Again, I'm just reviewing quickly. There are many missing values here, NAs, and it does make sense to forward this value here, 14.69, to this one, to the NA here. We don't know why there are NAs here. Maybe there was no trading at that time. So it doesn't harm if we're going to forward this value to this NA value here. That's well and good, class. So what we did last time was to perform NA.LOCF. So when we run this now, so you can see now there are no more missing values because of the LOCF here, zero missing values. Okay, that's good, class, as we said, if it's a multivariate, univariate analysis, if we're modeling VIX. Okay, it doesn't make sense to remove the 92 missing values, but it makes good, solid, logical reason to perform an LOCF. But we studied last time that we're not studying VIX independently or individually. We are using VIX as a predictor or as a feature for in in explaining US dollar PHP returns. So we're going to merge the data, and it doesn't always mean that if you do LOCF for a certain asset or a certain feature, then that means that it's the best option already. So we were able to show that, in fact, what we did was to merge the USD PHP full VIX and Brent, and then omitted the missing values. And we said that we had, out of the 2915, by merging all of them, we have 2214 when we omit the missing values. Now, what if we have what if what we did was to first perform LOCF so that VIX will now be complete? Will the result be better if we merge now the completed VIX to all the rest? And we found out that that was not the case. Okay, I'll just fast forward. And in fact, when we did that class, okay, so let me see, let's run this class. Okay, so this one, these were the missing values class. These were the missing values. And then when we forward fill it, okay, just like what we showed a while ago, there were 92 missing values from VIX. And now after LOCF, there's no more missing value. There were 92 that will filled. And then let's now merge this with the USD PHP with the Brent. Okay, and what we saw was, in comparing it with just choosing the VIX that had 92 missing values, the result was, okay, 2214 if we 2214 preserved values if we did not perform LOCF, and then 2215 if we performed LOCF. And we said that there was only percentage-wise, it's the same. Whether you do LOCF or do not do LOCF, it's practically the same. There's only one row that was preserved when we did LOCF. However, there's a disadvantage class if you're doing LOCF, because as we said, it introduces quote unquote fake or pseudo values to your LOCF. So we would rather that we preserve the real value of LOCF and then merge with the US dollar PHP and the Brent prices, because the difference is only one observation, and it's practically the same, 76% retention. Okay, we mentioned this last time, class. Okay, here, to avoid introducing stale or fake values, and also just doing the inner join will be the simplest, safest choice. Okay, since LOCF did not appreciably increase the retention. Okay, so we're going to use the merge prices. Okay, the merge prices is the one that we created by inner join. Here, class. So let me go back to here. Yes. We first merge all the data, and then we said when we merge the data, it will include all observations that have missing values. And then we omitted the missing values. So we created another object called merge prices. So I hope you recall that merge prices contain the full data, open, high, low, close, volume adjusted, together with VIX and Brent. However, it's a clean data already, 2214 observations. Okay. Then when we get the returns, class, when we get the returns coming from our merge prices, because of we're getting the log returns, what happens is that one observation will be, the first one will have to be removed because it has no corresponding returns. Okay, so by way of review class, here we got the returns of the USD PHP rep, okay, the VIX and the Brent. Okay, so just to make sure that, okay, here, I'm printing merge prices here, class. Merge prices contain open, high, low, close, okay, volume, adjusted, and then VIX and Brent. So we merged the data from USD PHP full, okay, and VIX and Brent. Okay, I hope you got that, class. No? Okay, let me just close this for a while. Okay, so what we're getting, class, is only the closing prices here. Okay, we're only getting the returns of the closing prices, not the open, high, low, open, high, and low. So we're creating this object, USD PHP rep, and this is from the merge prices class. Again, merge prices, open, high, low, close, volume adjusted, all the 6 columns of your USD PHP object, and then plus your VIX plus your Brent. So we're only extracting, or we're only computing the returns of Apple close, and then, sorry, not Apple close, USD PHP close. Okay, and then log. Same thing for VIX return. We extracted from the merge prices only the VIX, and the Brent also only Brent. And as you know, class, when we get the daily returns, okay, you'll have introduced there a missing value, okay, which we're going to delete later. And then here also, class, we're creating a target, and the target class is T plus 1 advance, okay, because we would want that T plus 1, okay, let's say the value today, uh, we're going to use the value yesterday, and it should be predicted by the values today. Okay, so if you run this class, you'll now have USD PHP rep, VIX, Brent rep, and target. These 4 objects now. And these are all XTS objects, class. Then we merge them, class. Okay, we merge them. So we're creating this XTS object and a.omit merge of USD PHP rep, VIX rep, Brent rep, and target. And then we change the column names, because when we create the daily returns, it will automatically create the columns daily that return, daily that return one, etc. So we're changing the column names of this object that we created, final XTS, into USD PHP rep, VIX rep, Brent rep, and target. And then we remove all the missing values. Okay, and let's check how many rows of observations that we have. Because, okay, merge prices class contain, okay, 2214. Let's be 2214 class here. There's merge prices here. 2214 observations. And then, when we get the daily returns, okay, it will be decreased by 1, because there will be the last one class will have an NA value there. Okay. So let's run that now. Where's that? Okay. Here. Okay, we have the returns now. And then this one. Let's run this. So there are now 2213 missing observations and no missing values. Okay, let me pause for a while and ask you, class, if you were able to follow up to this point. If you have any questions, please feel free to ask them. I hope you're able to follow along up to this point. Waiting for your feedback, class. Okay, good. Thank you. Thank you. Okay, thank you so much. All right, then we need to create the same elements, the same returns. However, this time as a table class. If we check where's our final XTS? Let's print that. Final XTS here. It is an XTS object because it was derived from the merge prices, which is an XTS object. So you can see that this is an XTS object because of the index which occur as dates here. All right. So we need to convert this into a data frame, into a table by getting this index, okay, and making it as a column equal to date, and then getting this core data. If you recall, class, an XS object contain both the index and the core data. So we just create an object, a new object as a data frame where we incorporate a column called date, which we extract from this one, this index, and then the core data, this one. So that's very easy. Okay, so we have now here, class. Final table. So to make it easy to compare with final XTS, final table, data frame. Here we're creating this column date, and it's equal to the index of this one, the final XTS. And then also comma, the core data of the final XTS. Then don't give the row names, row any name. Okay. And then consider it as convert it as a table. A table is a special type of data frame. Okay, good. All right. So if you run that class, if you run that, okay, run. Okay, let's inspect our final table here. 22, 13 observations, 5 variables. Same as your final XTS here, class. And you can see now the date has now been inserted as a column. And all the other data coming from your final XTS will appear here also. Okay. All right. 22, 13 observations. Okay, please take note of that. Okay, what's next, class? Okay. And then here we're just checking, making sure, class, that our object class, the structure of final table, it will print to show the structure, and then also the class of the date column. So when we run this, okay, tells us print final table shape, how many rows? 13 rows. And then it's a table class, special type of data frame. 2213, okay, it's correct. 5 columns class, okay. And then $date, these are the variables, columns, $date, USD PHP rate, VIX rate, Brent rate, and the target. Okay. And you can see here that the date it's a date. So that's correct. We also got the structure of the date column, it's a date. All right, so we're okay, we're good. Okay, then last time we went to feature engineering. Once again, I'm going to go through this very quickly. Feature engineering class allows us to properly set up our features. Features in machine learning are your independent variables. In machine learning, the dependent variable is called the target. Okay, the one that we're trying to model. Okay, so what we did here, class, was to use log returns of USD PHP. Okay, the returns of USD PHP, because from research it has been established by so many findings that the prior values of your log returns of your exchange rate are good predictors. Okay, so what we did here, before we do that, class, we identified our parameters, tuning parameters, class. This is what we're going to use for our features. we're going to use simple moving average, RSI, relative strength index, volatility window class. Then we have moving average, convergence, divergence, Bollinger Bands, and our ADX class, active directory index. Okay, so we're going to make use of them later when we perform our technical indicators. So let's just first check class. Okay, this was assuming that we are again starting another session where we just want to check class if the object merge prices, because we're going to need that. If you recall class, what does merge prices contain? Okay, just show it again. Merge prices, that's an XS object containing your open, high, low, close. Okay, we need this class because for the USD full class, we need the high and the low. High and the low for your active directory index. Okay, so go back here. So it tells us if merge prices does not exist, then stop and then send this message. Merge prices not found. But we're sure class that it will be found. And if it's found class, it will now count the number of rows of merge prices. It will give the head first 6 observations. Then it will print the column names of merge prices. So let's run this. Okay, so here it will print, okay, cut shape here. Print this. So what's the shape? Number of rows, 2214. Then head is the first 6 observations class, right? So it contains open, high, low, close, volume, adjusted, VIX, and Brent. Okay. And then get the column names. What are the column names here? Open, high, low, close, volume, adjusted, VIX, and Brent. Okay, so that's what this gives us. So it just confirms that we have the merge data. Merge prices, I mean. All right, so let's create this now. If you recall, class final table, this contains the, okay, this contains the returns class, diba? Final table, USD, PHP, RET. Okay, so just to make sure class, here, the VIX rep, the Brent rep, and the target. That's your final table. This is a table class. It's not an XTS object. So we're creating, to preserve the final table class, we're creating an object called data for fits. Okay, let's run this. And then here class, let's print data for fits. Okay, it also contains 2213 observations. Okay, 2213 observations. The date, the exchange rate return, the VIX, the Brent, and the target. Okay, let me pause for a while, class, and kindly confirm if so far you're able to follow. Okay, good, thank you. Okay. All right. Salamat, class. Thank you, thank you. I appreciate your feedback. Okay, so we said that practically the first feature that we can use are the log returns of our target variable, which is USD Philippine peso returns. So we can use this very simple code class, the loop code, where it will look from K from 1 up to log max. We already defined log max above, it's 3. So we're using log 3 logs in order to include as a feature in predicting our USD PHP. Okay. So this one makes use of the lag function. You know this class, we used this before. The lag function will create an object which is the lag of your variable. Okay, so lag of here class data for features of the US PHP rep. Take note here class. Here, it will get the lag of this USD PHP rep. And then, okay, from lag 1 up to lag 3. Okay, and then it will combine it with data for fetch object. It will include the column name. Okay, the column name class is your paste USD PHP ret class, and then you have here K class. What does K mean? K class is from 1 up to 3, right? The K there. So it will include USD PHP ret. It will paste 0 means it will append USD ret lag 1, USD ret lag 2, USD ret lag 3. So magiging tatlo siya, no? Okay, and then it will include it. It will append it with data for fetch. So let's run data for fetch class here. Okay, and let's check data for fetch now. Yes. Okay. Here class, we appended return lag 1, return lag 2, return lag 3. Still 2213 observations. Okay, so we keep on doing that for all the features that we have. So let's now go to SMA class. Simple moving average, we learned this in the past. We're using two SMAs, SMA 5 and SMA 10. SMA 5 and SMA 10 class are simple moving averages. Okay, so here we first remember merge prices class. Merge prices. What are merge prices? Okay. Okay, remember class, merge prices. It contains what? Here, no? Okay, but careful class, you have 2214 observations here. No? And then, okay, so what do we do here? We create this object, USD PHP close prices, and we extract the closing prices coming from the merge price, object merge prices. Okay, so let's run this. Okay, USD closed prices is, it's also an XTS object, and it contains 2214. That's why it's important. It's important class to check the number of rows, because sometimes if you have not, what's the term for that? Unequal number of rows, and then you're trying to create a whatever process out of it, then there might be a problem with that. So let's first create class, this one, SMA class, no? So where is this coming from? Coming from USD PHP close prices. N is equal to short, which is 5. So it will compute for SMA. So let's run this both. Okay, so let's check SMA short and long. Okay, take note, SMA short is 2214 observations, no? And then, okay, you have here SMA long 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th class, the 10th. So you add the first 9 observations together with the 10th and then get its average. Okay. Also with the short. Now, what happens, class, if we add this to, append this to Okay, so we're creating this object data for fits SMA short, and then we're getting the core data of our XTS, and then we will have to match, okay, our final XTS. What's our final XTS class? You recall our final XTS? Okay, so it pays class to check once in a while because I observed that we can become very careless and then just keep on running and without checking class. Final XTS has 2213 observations, right? And then SMA has this one class, SMA short XTS has, okay, 2014 observations, okay, 2214 observations. So what will happen? If it matches class, if it matches the 2213 and the 2214, then what will prevail, of course, is the 2213, okay? One has 2214, the other one has 2213. So it's like an inner join. So what will only prevail are those dates that are common to both. Therefore, the 2213 will prevail. Okay, so if I run this class, let's run both the X, the long and the short, control enter. What happened now? Let's check our, okay, where's our, here. Okay, class. Notice that we still have 2213. So even if SMA short has 2214 observations and SMA long also has 2214 observations, still what prevails is the 2214. We just have to make sure, class, that pareho lang yung ano, no? We have the same. We have the same number of observations. Okay, here. You can see 2213 class. Okay, so no problem so far, class. 2213 observations. Even if class short and long has 2214 observations. What what uh, what uh, how was that resolved, class? Because of this match. We're matching the final index, which is final XTS, which is 2213 observations, and SMA short 2214 observations. So what will prevail is 2213. All right. So once again, let me uh, ask for your feedback, class, if that's clear. That clear, class? Okay, thank you. All right. Thank you. Okay. Okay, and then I said, class, that another way to do your SMA is a rolling mean, class. But so this is from the zoo. So rolling mean, class, means that you keep on uh, you have your specific mean, okay, the number of periods. So for example, for short, it's 3. And then you keep on moving 3. Okay, so just to illustrate that, let's say this is our, what can we use? Okay, this is our, let's say, returns, no? So if it's an SMA 5, let's just use 3. So this 3 class. You get the average of this 3. And then that will be the value here on the third day. And then next one, you roll it over. Next 3 class. And then that will be the average for this one. So that's the same as SMA 3 class. Or if you're using If you're using zoo, then the function is roll mean. Okay, you have the same result. Okay, for this one. Okay, I'll not run that anymore. We have run that in the past. Okay, what's important is that we were able to already incorporate the rolling mean or the SMA short here. Oops, what happened? Why are there four here? Can you check, class? Do you have that? This should be 10. Okay, let me check. My long SMA long. Oh, I see. Class here. Please change this. It should be yeah, SMA long SMA here class. Here. Long. Okay, good. That's why it's important to check your data once in a while, class. Okay, I'm sorry, I use SMA short and short. That's why when I check the data forfeits, okay, why is this also 4? If it's SMA 10, then it should have 9 NAs, and then the 10th one should be the average. All right, so let's I'll rerun this class. Okay, that should be okay now. Okay, there you go. Okay. I think this was a repetition. Short, long. Okay, sorry. This is just repeated. Okay, then we have RSI class, relative strength index. Okay, I'll leave you class to please do some reading about what this technical indicator does. Okay, we're focused now more on the machine learning aspect of this. I would that you are looking at what's the purpose of using RSI, what's the purpose of using SMA, although we had a partial discussion of this. So this is just RSI class. Okay. And then again, the USD PHP closing prices. We already defined this above, RSI underscore 10. And then once again, we're going to append it to the data forfeits. Okay, so let's run this. And then we now have here our RSI. Here. RSI. What's our default here, class? For RSI, the default is 14. Okay, 14. And there's a very simple formula to compute for this, but I just want you to find out about that. Although I think I shared it with you last time. Okay, so these are 14, and then the 15th will be your first RSI. Okay, so let's go here now. MACD class. You need to identify 3. Okay, fast, slow, and the signal. Okay, let's check. We're creating this MACD list. Okay, MACD. And then we're creating this XTS object. XTS coming from this list. Order by index of your merge prices. And then change the column name into MACD line and MACD signal. Okay, if you run this class, okay, we have created this MACD class, MACD object. Fast, slow signal 12, 26, and 9. That's the benchmark. That's the default. And then let's append it to our data forfeits. This one. Let's check our data forfeits. Okay, it's 2213 still, and then we have this MACD line and MACD signal. Okay, all good. Okay, I hope we get to LN. All right, then Bollinger Bands. We had a problem with this a while ago, but I hope it's okay now. So we're creating this Bollinger Bands using B bands from TTR, okay, on the closing prices, and then N is equal to BB period, okay. We have defined that class. BB period is 20, okay. Standard deviation is equal to 2. Then we create BB width. Okay, let's first do this. Okay, and then BB width up minus down divided by the closing prices. Okay, so let's check. BB width class has how many? These are BB Bollinger Bands XTS. You have down, up, moving average, and then the percentage. Okay, and then if we, where am I here? Then we get the width, okay, which is just up minus down divided by the price. Okay, so the width is Bollinger Bands width. This one. So it's 2014 class, 2014 observation, just like your SMA. Okay. So if we're going to, once again, okay, we're going to append this. So it's core data of your BB width. We're going to match the index with the index of your final XTS, just like the one class we did in here. Where's the but RSI or SMA? It's the same. Okay, match the index of our final XTS. Okay, so where's that? Match the index of our final XTS with the index of the BB width. Okay, take note class, BB width has 2214. If we match that here, class, and let's check now. Here, all right, still 2213, okay, so no problem, 2213. Columns, okay? Just checking because a while ago we encountered some problems with that. Okay, so ADX class, ADX, we need, this is computed by, we need the high, low, and the close. The close we already have, so we need to incorporate the high and the low. So that's why we preserve class yung USD, the open, high, low, close, okay, the values, and we have that in merge prices. So we're creating this object called USD PHP high, low, close HLC. Then it's from the merge prices. Okay, all the rows are included, and then we get the high, the low, and the close. Okay, so let's create this USD PHP HLC. So let's check. here, class. HLC, 2014 observations again, okay? So no problem, we're going to match our final XTS with our ADX. Okay, then class, USD high, low, close. We can change the column names into column names, high, low, close to simplify it. Okay, let's run this. And then the formula class is just ADX. ADX of USD PHP ALC. So this contains high, low, and close. So this will now work. Control Enter. ADS XTS has how many observations? 24, 22, 14. Okay. 22, 14 observations. I'll leave you class to check the features of ADX. Okay, in the interest of time. That's very self-explanatory. So once again, we append ADX here, class. Record data. ADS XTS. And only the ADX here. Only the ADX. And then we match again index of the final XTS and index of ADX XTS. Run this. And then we now append ADX here in our data for FINLYTS. Here, class. There. Still 2213 for all. Okay, once again, class, I'll pause for a while and ask for your feedback. If you're okay so far. Now, if you might ask me, what's the choice of this class? As I said, class, these are technical indicators that are mostly used in predicting stock prices. Okay, there are indicators there, which means that they have a role in explaining your target variable. Okay, we're just limiting it to this well-known indicators. All right. So, okay, we also have another one, rolling volatility. Okay, we can do the roll apply. It's just getting the standard deviation plus. Vol window, I think. What's our volatility window? Is it vol here? Vol window 10. Okay, 10. All right. Standard deviation. Okay, once again, it will get 10, get the standard deviation of the 10 observations, then keep on moving by 10. Always it should be 10. Okay, so let's compute for this. Vol XTS. And if we check class Vol XTS, okay. So Vol XTS, it gives us class it's a vector, no? Numeric 2213 here. So you notice when we add this class, it's just in fact, why did I use core data? Okay, Vol XTS. It's just a vector. Okay, let me check class. It's just get head vol head. vol XVS 20, and also the okay, it's just a numeric vector. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, the 10th. So first 9 observations plus the 10th, then it gets the standard deviation. So, okay, it's a numeric vector class, so I wonder why I use core data here. Core data. Core data is used for an XTS object. Okay, anyway, if I run this, let me check. Volatility, yeah, it still runs. I think I made a mistake here, but it was still accepted because this is not an XTS object. Volatility. Okay, it's not even here in our, it's under the values. I wonder why it didn't generate a vol XTS. It's a vector. It's a vector. Okay, anyway, it run. But let me just check class. Control Alt I. Let's just double check. Control C, Control V. I'll just create okay. Okay, I'm replicating the existing data for fixed volatility. And then what I'm going to do is I'm going to append here Control C, Control V, dollar. I'll just call it vol, alt minus, and then it should be just vol XTS. Okay. So I'm not going to use core data class because this is not an XTS object. Let's see what happens, class. So data for fits, okay. Wait, what happened? No. Data for fits. Sorry. Data for fits 1 should be data for fits. Okay, sorry about that. Okay, so I'm just creating a new object called data fits 1 just to preserve class this data for fits because this is what we're using. Okay, I'm just going to create another object with a 1 so that I'll test class. What happens now if I data for fits $1, this is where I'm wrong. And then let's insert this object called vol, and it's the volatility XTS, which is your vector. Okay, let's print first data for fits 1. Let's print it. Just want to see what happens because I'm surprised why my code of core data ran a while ago. Okay, I didn't check kasi kung XS object siya. Data for fits. Where's that? Here, data for fits. Exactly the same class as data for fits. Data for fits 1. Kaso it included volatility. Wait, okay. So, did I run that already? If I run this now, yeah, it run. So it included this ball. It's the same. Okay. Okay, so I hope you're getting what I was doing, class. I actually, this was a mistake on my part because I have, as I showed you, class, this is not a core data. Okay, this is not a core. This is not an XS object, class. So why did I use core data? It's just a vector. When you run this class, the volatility XTS, it will not give you an XS object. It will give you a vector class. So yeah, I mistook I mistook it to be a vector. Okay, so the function role apply. We could have used another function called SD class. That would have worked. But here I'm using role apply, and then I'm creating this. I was assuming that it was an XS object class. So yeah, all right. So I'll just put some notes here. This object role XS object is not an XS object, but a numeric vector. Lagay ko lang class, no? Surprisingly, the code theoretically it should be then I'll put this okay, and just place some notes here class for my personal notes later on. Good thing it worked. Kasi core data, you're getting it from an XS object, and I'm wondering why it worked. Okay, did you get class what I was doing? Would you kindly chat, please, or was I talking to myself? Was I soliloquizing? I hope you got what I was doing. I got surprised class when I checked the type of data, ball XTS. I was expecting an XTS object, this one. But when I saw it under the values, the numerical value, oops. Feedback class if you got what I was actually discussing to myself. Hello, class. Any questions? Okay, thank you. Okay, thank you. All right. Okay, so just take note of this class. Technically, this is wrong. Core data, why use core data? My fault was, okay, my mistake was I did not check the type of data that's generated from the role apply. Okay, so when I just checked now, I didn't check it in the previous section a while ago. When I checked it now, because in the other section, we had a problem with B bands. Okay, so my mistake was I was not checking the results. So when we finally came here, okay, came here, well, in the key features, that's where the problems began. All right, so hopefully, since we have been checking each step of the way, then we will be okay now. All right, so last class, we will just rename our exogenous variables. Exogenous variables class are variables that are quote unquote from the outside. Why? Because all the other features, whether it's SMA or RSI, these are all extracted actually from your USD PHP. Okay, if you recall, RSI, MACD, these are all from your target variable, USD PHP. Okay, now VIX and Brent are not from USD PHP. So that's why they're called exogenous variables. Okay, so let's just rename them VIX current and Brent current. Okay, so I'll run this. Okay, so you now have data for VIX. There you go. Okay, I think I need to remove the volatility one here. Okay, so let's, I don't know if you run that. I'll just remove that here. Okay, what's that? Just to make sure it doesn't create it's here class. RM, remove data for fixed dollar volatility one. I'm removing that class. Control enter. Wait. Must contain. Okay. Hold the line class. I can choose RM. Okay. Sorry. RM is for objects. Okay. I made a mistake here. I have to do some adjustments. Anyway, class. Okay. So I hope you did not commit the mistake of including this one class. Okay. Let me just leave that as is for a while. Okay. And so anyway, I'll define the features class. Okay. So now we'll remove the missing values class, the NA values from data for fits. Okay. So remove it. Okay, there you go. No more missing values. And then I'll define the key features here class. So I'm creating this object, key features. What are the features or independent variables that we're going to use? You have USD, RET, lag1, lag2, lag3, SMA short, okay, referring to this one class. SMA short, SMA long, RSI, MACD line, MACD signal. Okay, RSI, MACD line, MACD signal, BB width. Okay, is it correct? BB width, okay. And then volatility, I'm skipping volatility one plus. And then VIX current, and then Brent current, and then target. So we're now creating this object called key features. Okay, let's run this. Okay, so we now have key features, which is a character vector. This one. If I print key features, Okay. So 14 key features all in all. Okay, then so we're going to subset because data forfeits contain the date, USD PHP rep, VIX, Brent rep. So we're going to subset and just get the key features. There are all in all 19 columns here because it includes the date, USD PHP rep, VIX, Brent. So we'll just need the target and the other indicators together with exogenous variables. All right. So data forfeits just subset all the rows, but just get the key features here. Okay. So if you check final features class, there you go. So final features is only 2180. Okay, a while ago it was 2213, but because of the the missing values which were removed, we only now have 2180 observations. Okay, so let's print the final data set feature engineering. Okay, we did not include the volume because USD PHP has no volume class. If this was an asset, a stock price, a stock class, then if there's a volume, then we would have included it. How many rows does the final features have? Okay, how many columns? And show the first 6 observations. Let's run this. Okay, there you go. Final data set shape after feature engineering, no volume, 2180 rows, 14 columns. And then here, first 6 observations. Okay, so again, please check class. We have finally completed step 2 class, and we'll begin with step 3 now. At least up to wherever we are able to start step 3. Are we okay so far, class? Okay, thank you. Thank you, Juan. How about the others? Haley, thank you. Moises, thank you. Paula. Okay, I hope the others are able to follow class. If you have any questions, please feel free to ask your questions. Jello, thank you. Okay, so that was 2 weeks of step 2. But anyway, also my fault because I had some mistakes while doing step 2. Okay, so let's now go to step 3, guys. And step 3 is all about splitting our data because we're not going to use all of the 2,180 observations for our final features. Okay, because that will be we will be having class what we call overfitting. So we're going to split it. And unlike class when we have classification class, where you can randomly just split your data in any direction, as in time series, you cannot do that because we have to preserve the temporal arrangement of our data. So let's first the number of rows and row of final features. Let's print it. And what we're going to do is let's use an 80%, 20% split. So, and the trained data set will be using the floor function n rows times 80. Okay, so let's run this class. Okay, so all in all, 2180 observations. We're going to put 1744 to our training data set. And take a look at this class. The next code is our trained data set will be coming from our final features. Okay, it will include only for the rows 1 up to 1744. Okay, so we're preserving the logical order. Okay, and then include all the columns. For the test data set, it will also be from the final features, and then take note of this. It's ntrain class plus 1. Okay, ntrain plus 1. So that's 1744 plus 1. Okay, so that's 1745 up to n rows, up to the last row at 2180. Okay, so I hope you got the logic of this, and then include all the variables. Okay, so let's print this class. Print training set, number of rows of our trained data. Okay, then rows, and then round 100 times n row of your trained data divided by n rows. And we're just getting the percentage. And then on the other hand, let's also print the test set, number of rows of test data, and then also get the percentage. Okay, no decimal place. Let's run this. So take a look at the print class. Training set, 1744 rows, which comprises 80%, and also the test data set, 436 rows, 20%. So everything class, the 80%, 20% is preserved. Okay, kindly chat, please. Once again, I'd like to get your confirmation if you were able to get that. Oh boy, time flies so fast. Okay, so this one class, just a quick check. The number of rows of our data fits, okay, is not equal to the number of rows. Okay, because n rows class, n rows should be the number of rows of our data fits, which is equal also to the number of rows of our final features. Okay, so let's run this quickly. All right, so okay tayo, no? Okay. All right, so let's just check class. Let's just check here. What we're going to do is, if you want to know from what date to what date class is your training and your testing. Okay, here I'm creating this object train. Okay, it's not class train data, no? It's not train data, it's train dates. Okay, this is just to determine ano ba yung dates natin ng training at saka testing. Okay, so if I run this class, okay, train dates, so data for fits class, kasi yung data for fits natin class, take note here. Yeah, siya yung my date class, di ba? May date yung data for fits natin. So what we're going to do is ask, ano ba yung dates ng 1 up to 1744 ba yun? Okay, and then 17 whatever up to the last. We're asking for the dates. Just if you're interested to know the dates class. Okay, so dito, so train dates class, di ba? From 1 up to n train, yung training data set natin. Get the minimum up to the maximum of train dates. So it will print class the dates for from the beginning of train dates up to the maximum. Yung maximum niya class, yung n train. Ito. Here. 1744 class. And then si ano naman, si test naman, titingnan niya yung minimum na test date hanggang maximum na test date. Okay, so if I print this class, okay. So ang train period natin is 16486 up to 19363. Now, in our class, just like in Excel, yung mga dates class, they have numerical equivalents. So if you want to get the numerical equivalent of 16486, gawin nating dates class, no? So as that date 16486, and then ang start origin class is ito class yung day 1, 170.0101. Okay, that's in R, that's day number 1. Okay, And then we're just going to dito class, kasi dito, if you run this class, control enter, okay, it will give you the date. No? So from 2015, February 20, 2023, 0106, ito yung training natin. And then 2023, 0109 hanggang 2024, 1227, that's our testing data set. And if you want to convert this into a weekday class, ito yun. No? So just take a look at this function. Simple lang naman siya class. Inulit lang yung as that date tapos convert into a weekday. Okay? So if I run this, convert lang natin yung mga dates into a weekday. So ito, no? So yung sa train natin, it started on a Friday and ended on a Friday. Yung testing natin class, okay? 19363 Friday. Bakit kaya Friday to, no? Friday and Monday. Ano ba yung nauna dito? 19366. Sorry. Okay. So 16486 start na Friday. 16486 up to 19363. 19363. So that's a Friday. 19366. Something's wrong here. Dapat hindi Friday to. As that date, tapos 19, sorry, this is 19366 class. Paki-change lang to class. This should be 19366. And then weekdays, as this should be, mali din to, no? 200-20084. Sorry, class. Kasi dapat kung Friday nag-end siya, dapat Monday to, no? Okay, run. Ayun, tama na, class. So, si training data set, nagsimula sa Friday, nag-end sa Friday. So, si testing data set class, true enough class. So, pag nag-end ng Friday si siyempre yung next trading day, Monday na, doon na nagsimula si So, wala siyang overlapping. Okay? So, it's time na pala class. So, okay. So, ganun talaga. Hanggang dito lang muna tayo, no? I think did I give this? Hindi pa, no? Okay, sige. So, we will attempt class. Last week na next week eh. So, next week dapat na tayo, let me first, I-discuss na natin class sa Friday yung how we're going